Hello everyone, I hope you're doing well. So in this video, we're going to discuss all problems except the F1 for Codeforces Round 883, which was headed for Division 3. So like after completing all of these problems, I was too exhausted to think harder on the F problem. That is why I was not able to solve it, and I have no hopes of solving it now, only 13 minutes remaining. So I decided to make a video, and for today's contest I believe the problems were not very difficult in terms of idea, but they were heavy in terms of implementation, right? Some problems require you to implement the problem properly or required you to write some big codes, right? So for Div 3 now it was pretty good, and let us discuss the problems now, starting off with the first problem. So let us start with the first problem, and this problem statement is a bit confusing, so I'll just simplify it for you. So basically we have been given n different nails and each of them has been associated with a height, right? So ai is going to be its height at which it is fixed, and bi is going to be the length of the rope connected to it. So for example, let's say we have a nail at height 4 and a rope of length 3 is connected to it. So one end will be connected to the rope and the other end will be connected to the candy. Similarly, now we have a nail at height 3 and it will have a rope of length 1 connected to it. And at the end, we will have a nail at height 1 and a rope of length 2 connected to it. Right. So one end will be connected to the nail itself and the other end will be connected to the candy. Now we have to tell the minimum number of ropes that we have to cut so that the candy touches the ground. Right. This is our whole question. So let me just explain you this with the help of some examples. So we need to first understand when does a nail prevent a candy from touching the ground. So it will only happen when, let's say this is a nail and some rope is connected to it and this is the candy, right? So we are just going to ignore the height of the candy in this case, and this is not required in the question actually. So let's say this is at height x, right? And this particular height is, let's say, y, right? So if x minus y is greater than 0, that means there is some distance remaining below it and it is still not touching the ground. So for every nail for which x minus y is greater than 0, that means if I don't cut this rope, the candy will never touch the ground, right? So this is a simple equation. Now you have to do this for every nail, and whenever you will observe there is a nail and there is a length and there is a rope of length, let's say y, and this is at height x. So whenever x minus y becomes less than equal to 0, even if I don't cut this rope, the candy will still be touching the ground, right? So this was the only observation in this particular case, and you just needed to count the number of nails for which x minus y is greater than 0. So this will give you a final answer, and the only observation is if a nail is attached at a height x and it has a rope of length y connected to it, then if I calculate the value of x minus y, it is going to give me the distance of the candy from the ground. So if this is non-zero, that means I need to cut this particular rope, otherwise I can just leave it, right? So let me just show you the code for this problem now. So you see that what I've done is I've taken an integer n and I've initialized my answer with 0. I just make a simple for loop, and I take two input values x and y. I calculate the value of x minus y. So this particular operation where I calculate the maximum 0 and position is not actually required. You can totally skip it. You just have to take care of this particular part where I am doing answer plus is equals to position is greater than 0. So this expression is a boolean expression, and when position is actually greater than 0, it is going to return 1, otherwise it is going to return 0, right? So this is exactly what I want. When position is greater than 0, I need to add 1 to my answer, and at the end I can just print my answer. So this was the solution to the first problem. Now let us have a look at this second problem. So this is also a very basic problem. They are just saying that there are three types of characters that we have, that is a cross, and O, and a plus sign, right? And a dot sign denotes an empty cell. So these are the four characters that we'll be having in a 3x3 grid, right? So you know the basic rules of tic-tac-toe, and that is, let me just explain you with the help of examples. So if this is a grid, right? So if either any row is filled like this or like this or like this, right? So this particular character is going to be a winner, right? Whichever one of the characters fills the entire row. Now similarly, Similarly, any one of the characters, if they fill the entire column, this is going to be the winner, right? Similarly for the diagonal as well. So there are three cases, one for the rows, one for the columns, and one for the diagonals, right? Since the grid is only 3 by 3, we just have to check these cases, and we have to tell the winner if there exists any, and if there does not exist any winner, we just have to print that it is a draw, right? So the winner can be three types. One can be X, and one can be plus, or one can be O, right? So these are the three types of winner that we can have. Now again, what you can do is you can just create an empty set of characters. So this is just how I implemented it. You can obviously have multiple different ways of solving this problem. I just found this way more convenient than the others. So what I did was, let's say I want to check for this diagonal. I will push all the elements in this diagonal into my set, right? And at the end, I can check if the size of set is 1. If the size of set is 1, that means all the characters that are present on this particular diagonals are same. So either they will be one of these three characters, or they can be a dot, right? Because all of the three characters in the diagonal can also be a dot, right? Now, if the size of the set is 1 and it is among one of these three characters, then I can print that particular character. Otherwise, I can just leave it, right? So I will do the same thing for all the rows, for all the columns, and for all the diagonals. And even if I get an answer in one of them, I'll print the answer and just return. Otherwise, if I don't get an answer in any of them, I can just print that it is going to be a draw, right? So this is the second problem. Let me just show you the code. So the code is a bit messy for this particular problem. You see that it is a pretty long code, but the idea is very simple. And if you have another way of solving this problem, you can definitely use that way. The idea will be just to check all the rows, columns, and the diagonals. So you see what I do here is I create a double dimensional vector of 3 cross 3, and I just take the input in the vector G, right? Now I create a set of characters, and you see that I am creating a for loop from I0 to 3, similarly a for loop from J0 to 3. So I am inserting G of Ij into my set. So you will see that initially the value of I is 0 and J is going to be from 0, 1, 2, right? So if I find the value of G of Ij, it is going to traverse through all the columns of the 0th row, right? So if in the 0th row the size of the set is 1 and it is not equals to a dot, that means I found my answer. Since all the characters are same, and I can just print it. And if I found the answer, I can just directly return from here. Otherwise, I just clear the set and I again run a simple for loop. So this time I am inverting the positions of J and I. So this will help me to check all the characters in the 0th column, right? So this was for the 0th row, and this is going to be for the 0th column. The exact same thing I am doing here. If I feel that I have found the answer, I just print it and return. Otherwise, I clear the set, right? So and the next time the value of I is going to be 1, and this is going to be from 0, 1, 2. So this part is actually going to store all the characters in the 1th row. Similarly, this part is going to store all the characters in the 1th column, right? So this will work independently. Now at the end, I also need to check for the diagonals. So this is the top left to bottom right diagonal. So it is going to be G of II, right? And again the same thing I am doing here, and I clear the set. If I found the answer, I can return. Otherwise, I clear the set. Now again, I have to check for the other diagonal from the top right to bottom left. Again, I do the same thing. I push it into my set, and if I found my answer, I just print it. Otherwise, I print draw. So I did not return here because this was my absolute last case. And if it is not even accepted, then I can just directly print draw, right? So this was the whole solution for the second problem. And let us move on to the third problem. So this problem was not very difficult. But again, the problem statement was big and it had some implementation. So for this, to solve this particular problem, they have defined a scoring system, right? So what is the scoring system? It is exactly similar to what we have in an ICPC contest, and let me just define it for you. So for example, if your team solves 5 problems, right? So your total points will be 5, right? So the teams are ranked on the basis of these points. If multiple teams have the same number of points, then they are ranked on the basis of penalty. So all the teams are sorted or ranked in order of increasing penalty, right? So how do we actually calculate this penalty? Let us discuss this part. So let's say you solve 3 questions, right? So you're going to solve them. Let's say you solve the first question in 10 minutes, then the second question in 15 minutes. So these are independent of each other. That means if you take 10 minutes to solve the first question, you take 15 minutes to solve the second question. This time is not cumulative, right? And let's say you solve the third question and you take let's say 5 minutes of time to solve the third question. Now, what is the total penalty in this case? So, the first question will require a penalty of 10. Now, you took 15 minutes to solve the second question, right? But the penalty that will be added will be from the starting time. So, that means when you solve this question, a total time of 10 plus 15 was already elapsed, right? From the start of the contest. So, this is going to be 25. So, now 25 is going to be added to your answer. So, the value that is being added to the penalty is actually the total time that has been elapsed from the start of the contest, right? Similarly, when you solve this next question in 5 minutes, then you will see the total penalty is going to be 25 plus 5, because this is going to be the total time elapsed from the start of the contest. So this value is actually coming out to be 30. So that means to solve the third problem, the total time elapsed from the starting was 30. So to calculate the final penalty, we are going to add all of this, and this is, I believe, going to be 65, right? But what if you solve the easier problem first? Let's say this was the easiest problem and you solve it in increasing order of difficulty, right? So this will take 5 amount of time. Now this takes 10 minutes, that means from the starting you have elapsed 15 minutes. This takes 15 minutes, that means from the starting you have elapsed 30 minutes, right? So if I add all of this, what happens? It is going to become 50, right? So you see that if you solve the problems in increasing order of difficulty, that means your penalty is always going to be less, right? Your final penalty is going to be lesser. Moreover, if you try to solve the problems in increasing order of difficulty, you have a total time of, let's say, capital T, right? So in order to solve more problems, this penalty part is okay, but obviously if you have solved more number of problems, then you will be ranked higher. So to solve more problems in the same amount of time, you will need to solve the problems that are easier or that takes less time, right? So for both of the cases, you have to sort the questions in increasing order of difficulty and attempt those questions first which take lesser time, right? So basically, once you have sorted the time for all the questions, right, you can calculate the total penalty taken by each member. You can calculate his total points, right? What are the total points or what are the number of questions solved by this particular person? So when I have these two information, my final task that has been given to us in the question is to find the rank of the first player, right? The rank of the first player means here we have been given the details of several participants. So we have to find the final rank of this particular participant. In case like there are multiple participants with the same rank, with the same points and penalty as this particular participant, this participant will assume the best rank possible, right? So this question was completely based on implementation, and let me just show you the code. So I'll be able to like explain you better this particular question with the help of code. So what you see here is I've created a double dimensional vector of size n cross m. So n is basically the number of participants and m is basically the number of questions for each participant. Now for each of the participants, I take input in it in v of I, right? Now I sort all the values of the time taken for each question, right? Now I initialize three variables: score, time and penalty. So score is going to store the total number of questions the current participant has solved. Time is going to store the current time that has elapsed, and penalty is going to store the total penalty that has been taken. So now what I do is, if the total time that I have taken plus v of ij, that means the time taken to complete the next question is less than h, that is the maximum time allowed, I'll add that time to my time variable and I'll update my score. Since I have to add the total time elapsed from the starting into my penalty, so I just add this time value to my penalty variable, right? Now what I've done is I created a class called info. So if you don't know how to use this particular thing, I highly recommend you to learn how to use structs or classes. Any one of them would work. You just need to understand how do you handle complex data types like these. So you see, I'm using an info class which is going to store three values: score, time, and index. So you can assume it to be a single element which is going to store three values. Like just like in pairs, we use a single element to store two values, but here I needed to store three values. That is why I'm using a class, right? So it is basically going to store the three values, and it is the same three values. It is score, time, and index. So we have discussed score and time, but why do we need index? So this is for two purpose, that at the end we need to find the rank of the first participant, and in case multiple of them have the same time and score, then in that case I'll have to sort them by index. Why sort them by index? Because the question asks us to print the first participant with the best rank possible, right? So if he has the first participant, we can just directly sort all the elements with respect to index, right? Now what I do is, this is my info constructor, so it will receive three values A, B, and C, and it will assign all of them to score, time, and index respectively. So you see, I'm just creating a new object here. So new item is going to pass these three values: score, penalty, and I. So this is the score, this is the penalty, this is the index. It is going to get passed into this particular constructor, and all of these values will get initialized. Now I can just push this new item into my points vector that I have created. So my points vector is actually a vector of this info elements, right? So if you have not studied this particular thing before, I highly recommend you to check this out, and because it is very useful to handle complex data types in contests, right? Now I can just sort all of the elements in points, and I can just sort them on my custom comparator. So what I do is, if the score is equal, I apply some logic, but if the score is not equal, I sort them on the basis of score. That is, A dot score should be greater than B dot score. That means the elements that are occurring first should have a higher score. If their score is equal, then I check if their time is equal. If even their time is equal, I sort them on the basis of index, otherwise I sort them on the basis of time, right? So at the end, what I can do is, I can just run a simple for loop. Now if points of index, that means if the current element's index is equal to 0. So remember, what was the index of the first element? It was 0. So if it matches, that means I found the current rank, and I can just print I plus 1. Why I plus 1? Because this was 0 based indexing, so I need to print it in 1 based indexing, and then I can just return. So this was all about the second problem. You see that this problem does not involve any complex logic. It is just sorting of all the elements. One sorting is here and one sorting is here. Other than that, there is no complex logic. You just need to know how to handle these complex data types, right? So let me just explain you this particular question now. That is problem D. So this particular problem says that we have been given some triangles, right? So these particular triangles are of this form. That means their height and base is fixed. All of the triangles that we have here have the same height and base, right? Now some of them might overlap each other, obviously, as you can see in this diagram. So we have been given the heights or the position of the triangles. So let's say this first position is 1. So that means it will start from y coordinate 1. The next position is 4. That means it will start from a y coordinate 4 here. And the next position is 5. That means it will start from y coordinate 5. Right. Now we have to tell the total amount of green ink that will be used to cover all these triangles. Right. So you see that it is overlapping. These two triangles are overlapping. So we are obviously going to save some ink from the triangle that is already covered behind. So let us discuss this question with the help of an example. So this is the question that we have, and you will see that this triangle is covering the whole area, and it is not being covered by any other triangle. So obviously the amount of green ink that is being used by this particular triangle is going to be the equal to its area, right? So that is basically base into height by 2 for an isosceles triangle like this. Now you will see what happens with this particular triangle that is covered by another triangle, right, like this one. So for this particular triangle, what I can do is, I can first add, since all the triangles have the same area because they are of the same size and width, I can let's say I have created a constant area, right, and I have stored it somewhere, right? So whenever I encounter a new triangle, I can just add this value to my answer. Now I check whether I need to subtract some value or not. In what case do I need to subtract some value? When some other triangle is overlapping this particular triangle, right? Like in this particular case, this above triangle is overlapping the triangle below it. How do I identify it? since all the triangles are of the same size, right, the above triangle will only cover an area within this triangle when its starting position, when the starting position of the next triangle is less than the height of this particular triangle. So let's say this triangle started at height, let's say 4, and it extends to a height of 2. So it is going to end at height 6. So if the starting position of the next triangle is less than 6, that means it is going to overlap the triangle below it, right? So this is the first understanding. Now the second thing that makes this question a lot easier is that the height of all the triangles and the width of all the triangles are same. So you will never encounter a case like this, right? You will never encounter a case like this where the triangle below it is covered partially, right? So this case, if it had occurred, this was going to be very difficult to handle. But since the height and width of all the triangles are same, it is always going to cover in a manner like this, right? So whenever it is covering a triangle below it, you see that it is nothing but also a triangle behind it, right? So this area is actually removed from the total area of my below triangle. So let me just also draw it here so that you can see it clearly. So if I extend this triangle, it would have been something like this. So this is the area that is being actually covered in both of them. So I need to remove this area from the triangle below, right? So the final conclusion is whenever I see a triangle is overlapping another triangle, what I can do is I can calculate this double area that has been calculated twice and I can remove it one time, right? So now the question is, how do I calculate this area actually? You will observe that this triangle is nothing, just a smaller version of the same triangle, right? So it is exactly the same triangle, just smaller in height. So what I can do is, first I have to calculate this intersecting height. I can calculate this intersecting height. So this smaller triangle is going to have the dimensions in the same ratio as of the bigger triangle, right? So let's say we have the breadth and the height like this, b upon h. Now the smaller triangle has some height, let's say h1. So I can calculate the new width or b1, right? Because they are going to be in the same ratio. So I can calculate it like b into h1 upon h is equals to b1. So with b1 and the value of h1, how do I calculate h1? h1 can be calculated by this area, by this length intersecting, right? So with these two values h1 and b1, I can calculate the area that is being covered twice and I can remove it from my current answer, right? Answer minus is equals to this particular value. So what I am doing is, initially I am just adding the area of the whole triangle and then I check whether some part is intersecting or not. If some part is intersecting, I calculate the area of that intersecting part and then I remove it from my answer, right? So this was the whole question. Let me just discuss this with the help of code. So this was actually the fourth question, D question. So you will see what I have done is I have taken everything in double and I have created a vector v of size n and I take input in it and I just calculate this constant value of area, that is d into h by 2. Now I initialize my answer with 0 and for each of those values what I do is I just add the area of a triangle into my answer. Now I check if there exists a next triangle or not, right? So if it is going to exist when I is less than n plus 1, and then I check what is the starting point of the next triangle. If this starting point is less than my current starting point plus h, that means they are going to intersect, right? So I can calculate the new height of the triangle, that is the intersecting part of the triangles. So I can calculate it by v of I plus v of h minus v of I plus 1, right? So this is the height that is actually intersecting. Now I can calculate the width by this particular formula, d by h into nu h. So this is just making use of the idea that both of the triangles are going to have its dimensions in the same ratio, right? So now I can just subtract this particular value, the area of the intersecting triangle, from my answer, that is nu h into nu width divided by 2, right? And after all of this has been completed, I can just print my answer. So this was the solution for the fourth problem. Now let us move on to the fifth problem. So I believe like it is just better to discuss the harder version because both of the problems can be solved with the code of the harder version. So we'll just directly discuss this particular problem to make the videos shorter, right? So the only difference between the two problems is that the value of n is 10 to the power 18 here, and the previous question it was up to 10 to the power 6, right? So the question says that there are some crystals or snowflake crystals that are of this particular format. So what is happening here is there is some value of k that exists, and this value of k is obviously going to be greater than 1 in any case, right? So whenever, so they have given an example when k is equals to 4. So let me just directly take this and explain you. So we have this diagram here. So you will see that the value of k is 4 here, right? So the value of k is 4 here. What happens when k is equals to 4? So the first element is this one, right? A central node. Now it will be connected to 4 other nodes, right? And these 4 nodes will be connected to 4 other nodes individually, right? So what is the total number of nodes here? It is going to be 4 raised to the power 0 plus 4 raised to the power 1 plus 4 raised to the power 2, right? So these are the total number of nodes. You can also calculate it is going to be 21, I guess, because 21 are the total number of nodes. So 4 raised to the power 0 is 1, 4 raised to the power 1 is 4, and 4 raised to the power 2 is 16. So this is equals to 21. Yeah. So this is the smallest snowflake that you can form. So let's say the value of k is 2. So let us draw a diagram for it. So there will be a central node and it will be connected to 2 other nodes, and each of those nodes will be connected to 2 other nodes, right? This is the smallest snowflake that we can form. So for this, the total number of nodes will be 2 raised to the power 0, 2 raised to the power 1 plus 2 raised to the power 2. So it is going to be 1 plus 2 plus 4, and this is going to be 6. And you can see this is 1, 2, 3, 4, 5, 6 and 7. So I believe that I have written it wrong here. 4, 5, 6, 7. Yeah. So this is 7. Right. 4 plus 2 plus 1 is 7. So our question is, we have been given a value of n, that is the total number of nodes in the final snowflake, and we have to tell whether there exists a value of k such that it is possible to form a snowflake with total number of nodes n. Right. So this k should be greater than 1. So this is our whole question. You have to tell whether it is possible to form snowflake like this or not. So how we can solve this particular problem? There are a couple of observations you need for this question. So the first observation is, let's say you take the smallest value of k. So that smallest value is going to be 2, right? Now if you take 2 raised to the power 0 plus 2 raised to the power 1, 2 raised to the power 2 up to 2 raised to the power 64. So 2 raised to the power 64, right, is approximately greater than 10 to the power 18, right? It is actually greater than 10 to the power 18, and you will see that a long has 64 bits. So the maximum value that you can represent with long is 2 raised to the power 0 plus 2 raised to the power 1 up to 2 raised to the power 63, right? This is the maximum value that you can represent. So if I just take 2 raised to the power 64, even a bigger value than this one, that means I am definitely going to surpass this particular value, 10 raised to the power 18, right? So what I am trying to say here is the maximum power that I have to take in any case is going to be 64. So this is the maximum upper bound. I already know that I can form an answer with 63. 2 raised to the power 0 plus 2 raised to the power 1 plus 2 raised to the power 2 up to 2 raised to the power 63 is already going to be greater than 10 raised to the power 18, right? So I took a even safer value. Now I know that 64 is the maximum power that I need for every other element. Let's say 3. For 3, I will obviously need a power less than 64. Similarly for 4, 5, 6 and 7 in it, and any number that I want, I would obviously need a power less than 64. So this is my first observation, right? So my first observation is, at max I need a power of 64 to form my answer, right? So this is my first observation. Now let us move on to the second observation. So we made the first observation on the minimum value of k. Now let us make an observation on the maximum value of k. What happens if we take the maximum value of k? So you will see that the minimum size of crystal is this, right? So if I take k, I will have to take k raised to the power 0 plus k raised to the power 1 plus k raised to the power 2, right? So the maximum value of k that I can take is about 10 raised to power 9, because 10 raised to power 9 square will be equal to 10 raised to power 18. Then I'll have to add 10 raised to power 9 plus 1. So this is obviously going to be greater than 10 raised to power 18, which is the maximum upper bound, right? So that means 10 raised to power 9 seems to be a good upper bound on the value of k. So that means at max I need the value of k to be 10 raised to power 9. So I have set two upper bounds from these two observations. The first upper bound is on the powers that I need. So at max I would need a power 64, and at max I need a value of k to be 10 raised to power 9. Right. Now to solve the harder version, what I can do is I can just brute force through all of these powers. Right. Let's say my answer is possible with the power of x. So what do I mean by this? That if my given input is n, then there will exist some power x. Let's say the number is y, right? So y raised to power 0 plus y raised to power 1 plus y raised to power 2 and so on up to y raised to power x is actually going to be equal to n. This is my assumption, that there will exist some value of y, that y raised to power 0 plus y raised to power 1 up to y raised to power x. If I sum all of these, it will be equal to n, right? Now I need to check whether there can exist such value of y or not, right? This is my whole task. So I'm repeating it again. I'm just going to traverse through all the powers from 2 to 64, because 2 is the minimum number that I have to take, right? And then I can check whether there exists a value of y such that the whole summation of this thing will be equal to n. So how do I check this? I can check this thing with the help of binary search. So what will be the range and idea of binary search? So first of all, let us discuss the range. The range will be from 2 to 10 raised to power 9. Why? Because k, the maximum value of k is 10 raised to power 9 itself. So let us just take an even better upper bound, 10 raised to power 9 plus 10. So this is our upper bound for the value of k, and the lower bound is 2. What is going to be my condition of binary search? So my condition for binary search is going to be, I am going to look for an element which has the summation less than equals to n, right? So let's say I find the value of y. I will calculate the value of y raised to power 0 plus y raised to power 1 plus y raised to power 2 up to y raised to power x, right? I add all of this value. If this value is less than or equals to n, let's say summation of y, so I is from 0 till x and y raised to power I. So if this whole summation is less than or equals to n, that means I consider it to be a valid answer, otherwise I don't consider it to be a valid answer, right? So this way I can find the greatest value of y which has this total summation less than or equals to n, right? Once I find this value, after finding this value of y, I can again find the same thing, right? The summation of this whole thing. And if this summation of I from 0 till x y raised to power I is equals to n, that means it is a valid answer. If it is less than n, that means it is an invalid answer, right? So this is what I am going to do. So I am going to find this value of y using binary search, and what will be my condition of binary search? I need to find a value such that it is less than equals to n. At the end, if the summation is coming out to be equals to n, that means it is a valid answer, otherwise it is not a valid answer. At the end, it is going to be equals to n or less than n, because this was my binary search condition, that it has to be less than equals to n. If it is equals to n, that means it is a valid answer, and I can just print yes. Otherwise, if for all the values after doing all the brute force, if I don't find an answer, my answer is going to be no. So let me just show you the code for this particular problem. So you see what I've done here is I created a simple for loop from 2 to 64. This is my brute force part where I am just brute forcing on the powers. Now I just create a range L from 2 and H till 10 to the power 9 plus 10, right? So I am assuming that the lower end is always going to be true and this higher end is always going to be false, right? So true means that if I find this value of y for this particular L, that is always going to be less than or equals to the value of n. So this is my assumption, right? Now I run this simple binary search. I calculate the value of mid. I will store the summation answer in this value variable, right? Now what I do is I just go through all the powers of 0 till I, right? So this is going to be less than I plus 1. So it is actually up to I. So I just do mid raised to the power j. So this is my exponentiation function. This is a simple binary exponentiation. You can also use some other function. it should work equally well. So I'll add this particular value mid raised to the power j to my value variable. So if this value becomes greater than n, then I can just directly break because there is no use. Otherwise, I can just continue adding. So at the end, if this value variable is less than equals to n, that means this is a valid answer and I can assign mid to L, otherwise assign mid to H, right? Now at the end, when I have a valid value of L, I can again calculate this value, and if this value is equals to n, that means it is a valid answer. I can print yes and I can just return. Otherwise, if after all the for loop I don't have an answer, I can just print no, right? So this was all about problem E. Now moving on to the last problem for today's discussion, and that is problem G. So if you are able to observe this particular problem, you will be able to solve this problem easily, because this problem is nothing but just a direct implementation of Dijkstra's algorithm. You just need to understand how to apply Dijkstra on this problem. Otherwise, you will be stuck forever in solving this problem. So what this problem says is, let me just explain you with the help of this example. So we have these values. So let's say the initial value is 5 and 4. So this is actually the number of symptoms that we can have, and this is the number of medicines that we have, right? So our initial symptoms are given like this, right? 1 0 0 1 1. So that means I have this particular symptom, or you can also say I have this particular disease, and so on, right? Now you have been given some medicine, right? So each medicine has 3 attributes. So the first attribute is the number of days you need to take that medicine, right? You need to take this medicine for 3 number of days for it to work. Now if you take this particular medicine, it will cure some diseases and it will give you some side effects, right? So curing this disease means, this one here means that it is going to fix your this particular disease or cure your disease of this particular type, right? So for example, if your symptoms were like this initially and you take the first medicine which cures diseases like this, so this disease will be cured and you will be left with the remaining 2 diseases at the end, right? Or you can also say symptoms. Now it is also of some side effects. So this is some side effects. That means basically in simple layman terms, it is going to give you this particular symptom. So you already had this symptom, this one, and it is also going to give you this one. So your final state will look something like this. So you are given an initial state, your current starting state, and you are given some medicines. Now each medicine has some number of days associated with it. That means you need to take that medicine for that number of days. Now each medicine also has some of the diseases that it can fix and some of the side effects that it will cause. So all of the bits that are marked as 1, your medicine is going to fix that particular disease, and all of the bits that are marked as 1 here, your medicine is going to give you that particular disease, right? This is the overall question. Now this question can be solved with Dijkstra's algorithm, but let us try to formulate how we can like jump from one state to other. So for example, your initial symptoms were like this, right? And you know that your medicine, this is the remedy, right? Your medicine is going to fix this particular disease, right? So how do I translate this information into the original state? What I can do is I can take all of these zeros, and for all the zeros in this I can convert them to 1, right? And all the ones I can convert them to zeros, right? So now if I write it, so you will see that if I take the bitwise AND of both of these values, then the final result will be like this, right? So this is actually what I wanted. Here it was 1, that means it was going to fix this particular symptom, right? So I mark it as 0 here. So when I take bitwise AND, that means whatever value was here in my original state, it is going to become 0. And for all the other symptoms that my disease cannot, that my medicine cannot fix, are going to remain unchanged. So I mark all of them as 1s, and whatever value is here, that will be copied. So this is how I can find out what are the diseases that will be fixed from this particular medicine. Now if you have to take the same thing for the side effects, so the side effects were 0 0 1 1 0. For this I don't have to do anything, I just have to take the bitwise OR of these 2 values. So all of the diseases that are 0 here are not going to affect my original state, but all the diseases that are 1 here are going to be copied to my original state. So my original state will look like this, right? So the final state will be this. So with the help of these medicines, you can find what are the new states that I can go to if I take this particular medicine. How do I find it? I will take all the diseases it can fix. I will invert all the bits and take the bitwise AND. So this is going to tell me what are the diseases that will be fixed. For all the side effects, I can just directly take its bitwise OR with my current state, and my final state will be this one. So if let me just write it formally also. So this is my current state. I have to take the bitwise AND with the inverse of remedies. I'm just calling it remedies, and with this whole thing I have to take the bitwise OR with side effects, right? So I've written it in some kind of a pseudocode. So this is my current state. I take the bitwise AND with the inverse of remedies, and I take the bitwise OR of all the value with side effects, right? So this is going to be my final state if I take any medicine, right? Now I know what is going to be the change in my state, and they have given us a very interesting thing that the value of n is up to 10. So there can be at most 1024 states, right? So these 1024 states can be represented as 1024 nodes, and now I know how do I go from one node to another. There are only 10 to the power 3 medicines at maximum, so I can easily apply Dijkstra's algorithm. I already know my starting state. My final state that I want to reach is 0, right? Because at 0 I will have no diseases and all the bits will be set to 0. So I just need to find the shortest path from the start position to this 0th position, right? So this was all about this problem. So let me just show you the code now. So I just open this. So you see what I've done is I've taken two variables n and m, and I created a distance vector of one left shift n because there will be n diseases, right? And I just initialize all of them with infinity. So this is going to store all my states that are possible. Now I take the string s and I've reversed it. So the reason why I reversed it is because normally when you convert binary to integer, you reverse it, because in binary what happens is the rightmost position is actually the least significant bit. So when you reverse it, it actually comes to the leftmost position or the 0th index. But you will see that this is absolutely unnecessary here. It's just that your states need to match. So if you use this reverse part, you will have to use it in all other parts as well. As you can see that I have used reverse here as well, and if I use reverse in other places as well, you will have to reverse it at all the places. And if you don't reverse this, you don't have to reverse it at all the places, right? All of these things should be consistent. It has to follow the same pattern. That is the only thing. Otherwise, you can choose any method, right? So this reverse was not actually required. I just did it during the contest. Now what I do is I try to determine my start position. How do I determine it? I just go through all the bits, and if s of I is 1, I just add one left shift I to my start variable, right? Now I will know what is my starting position. Now I will consider a vector of edges. So as you can see, again I have taken a custom class of information. So class info is going to store my AND mask, my OR mask, and my D. So I have taken these variable names AND and OR mask because in the example I have shown you that with one particular thing you have to take bitwise and for the other thing you have to take bitwise OR. So while implementing the code, I need to know what is with which value I need to take and with which value I need to take OR. That is why I have created the variable names like this. And D is obviously going to denote the number of days that the current medicine will take. So this is going to store the information of each medicine, right? So I can also define it as edges. Now I just take an input x as input. So this is going to be my number of days, and I take two input strings, right? I reverse both of them. It is not required, but if you decide not to reverse it here, you also have to reverse from here, right? And I calculate the value of AND mask and OR mask. As I have already explained you, I need to take bit 1 whenever a of I is equal to 0 in my AND mask, right? So whenever a of I is equal to 0, I have to take it as 1 and I have to add it to my AND mask. So I am taking one left shift I and adding to my AND mask. And whenever b of I is 1, I am adding one left shift I to my OR mask. So you see that it is 1 because I need to take the exact string. It is 0 here because I need to take the inverted string, right? This is the only reason. And now what I do is I create this new edge as x is the distance and mask and or mask. I am passing these values and this will be passed to my default constructor here, and all of these values will be initialized and I can just push back this new edge into the edges vector. Now I just create a priority queue. So this priority queue is going to store pairs. The first part of the pair is going to store my current distance and the second part is going to store my current state. So it is greater int because I want the first element to be as small as possible in my priority queue. Now I just mark my d of start as 0 because this is going to be my starting position. Now while my priority queue is not empty, I can just find out the distance and the current state and I just assign it to these two variables and I can just remove it from my priority queue. Now I am just trying to visit all of the edges, and for each edge I can calculate the new state as state and edges of I and this particular value and mask, right. So I am taking bitwise and with this and mask, and I am taking the bitwise or of this new state with the or mask, right. So we have already discussed what is this and mask and or mask. Now what I do is, if the distance of the new state is greater than the current distance of the state and the distance of this particular edge or the number of days you need to take this medicine, then I'll update this new distance and I'll push it into my priority queue. At the end, after all of it has been executed, if the 0 state is not reachable, it is going to be infinity, the distance is going to be infinity, and hence I print -1, otherwise I print the distance of 0, right. So this was all about the last problem. I hope that you guys were able to understand the solutions. If you guys did, then consider dropping a like on this video and don't forget to share your thoughts in the comments, because your engagement with this particular video really helps the YouTube algorithm to understand that this video is actually helpful for you and it will be able to reach more number of people like you who want to keep solving new problems. So I see a lot of people who watch these videos have not subscribed yet. In case you're one of them, then definitely consider subscribing. It's always free of cost and you can always unsubscribe if you don't find the videos interesting later. So share this channel with your friends. Until the next video drops, keep coding, stay safe, bye bye.